Hey everyone. Welcome back to our channel. If you're new here, I'm so glad you're here. In today's course we are going to learn about artificial intelligence. Here is an outline of today's course. In this course we have 7 chapters. In each chapter we are going to learn amazing things about artificial intelligence. Before completing this course, don't forget to share and subscribe to the PIXIPACE YouTube channel. Do share it with your family and friends to spread the knowledge. Chapter 1. Introduction to Artificial Intelligence. What is artificial intelligence? Artificial intelligence, AI, is a broad term used to describe any type of computer system that is designed to think and learn like a human. AI systems are capable of making decisions and solving problems without the need for human intervention. AI is used in many different fields, including robotics, natural language processing, computer vision, and machine learning. AI can be used to automate tasks, provide better customer service, and improve decision-making. History of AI. In the 17th century, philosopher and mathematician Gottfried Leibniz began to research the possibility of creating machines capable of performing complex tasks. He proposed the idea of a calculus ratiocinator, or a machine that could solve mathematical problems. In the 18th century, mathematician Charles Babbage proposed the first mechanical computer, the analytical engine. Although Babbage was unable to build the machine, he provided a blueprint for it, which was later refined and developed by Alan Turing in the 1930s. The term artificial intelligence was first coined in 1956 by computer scientist John McCarthy at the Dartmouth Conference. At the conference, McCarthy and his colleagues discussed the possibility of creating machines that could think and reason like humans. In the 1960s, artificial intelligence began to gain traction as a field of research. Researchers developed programs to play checkers and solve algebraic equations, while others put forward theories of artificial intelligence and cognitive science, such as Herbert Simon's theory of bounded rationality. Since then, AI technology has developed rapidly and is now used in a wide range of applications, from medical diagnosis to self-driving cars. AI is used to power virtual assistants, such as Amazon's Alexa, Apple's Siri, and Google's Assistant, and to improve the efficiency of manufacturing processes. AI has also been used to develop computer vision, natural language processing, and robotics. AI technology is advancing rapidly, and its potential applications are only beginning to be explored. As AI technology continues to develop, it is likely to have a profound impact on the way we live and work. AI applications. AI applications are used in a variety of industries, including healthcare, finance, education, transportation, and manufacturing. 1. Healthcare. AI applications are becoming increasingly common in the healthcare industry. For example, AI algorithms are being used to diagnose and treat diseases. AI-based systems are able to analyze large amounts of data and identify patterns, which allow them to make more accurate diagnoses and suggest better treatments. AI-based systems are also being used to detect early signs of disease, such as cancer, by analyzing imaging data. 2. Finance. AI applications are being used in the finance industry to automate processes and make better decisions. For example, AI-based systems can be used to detect fraudulent activities, such as credit card fraud and money laundering. AI-based systems can also be used to analyze market data and identify trends, allowing financial professionals to make better investment decisions. 3. Education. AI applications are being used to enhance the educational experience for students. For example, AI-based systems can be used to provide personalized learning experiences by analyzing data from student interactions with the learning material. AI-based systems can also be used to provide automated tutoring services, which can help students learn more efficiently. 4. Transportation. AI applications are being used to improve the efficiency and safety of transportation systems. For example, AI-based systems can be used to detect potential traffic congestion and route vehicles around it. AI-based systems can also be used to detect hazards on the road, such as debris or animals, and alert drivers to take precautions. 5. Manufacturing. AI applications are being used in the manufacturing industry to automate processes and increase efficiency. For example, AI-based systems can be used to monitor production lines and detect potential issues, such as quality defects. AI-based systems can also be used to optimize production schedules and reduce waste. Chapter 2. AI algorithms. Heuristics. Heuristics in AI is a type of problem-solving strategy that uses a set of rules or guidelines to make decisions. Heuristics in AI can be used to find solutions to difficult problems by taking into account various factors such as time, cost, and availability. Heuristics are often used to solve problems that are too complex for traditional methods. For example, a computer program designed to play chess may use a heuristic to determine which move is the best in a given position. The computer program will consider factors such as the pieces on the board, the player's position, and the opponent's position before making a move. By using heuristics, the computer program can make a decision without having to search through all possible moves. Another example of heuristics in AI is when a robot is used for navigation. The robot can use a heuristic to determine the best path to take by considering factors such as the terrain, obstacles, and other potential paths. By using heuristics, the robot can make decisions quickly and accurately. Heuristics can also be used in machine learning. For example, a machine learning algorithm may use heuristics to determine which features are most important for a given task. By using heuristics, the machine learning algorithm can make a decision about which features are most important without having to consider all possible features. This can help reduce the time and resources needed to train the algorithm. Heuristics can also be used in natural language processing, NLP, to determine the meaning of a sentence. For example, when a sentence is parsed, the NLP system may use a heuristic to determine which words are important and which can be ignored. By using heuristics, the NLP system can quickly understand the meaning of a sentence without having to consider every single word. Heuristics can also be used in artificial intelligence, AI, to determine the best course of action in a given situation. For example, a robotic car may use a heuristic to determine the best route to take when driving from one destination to another. By using heuristics, the robotic car can make decisions quickly and accurately without having to search through all possible routes. Search algorithms. Search algorithms in artificial intelligence, AI, are used to explore the search space of a problem in order to find a solution. A search algorithm is a collection of instructions that can be used to traverse a search space or graph in order to find a specific solution. AI search algorithms are used to solve complex problems such as game playing, pathfinding, scheduling, and planning. Examples of search algorithms in AI. Brute force search. Brute force search is a technique used to exhaustively search through the search space of a problem in order to find a solution. It is a very simple technique and is used for problems with a relatively small search space. For example, it can be used to solve the 8 puzzle problem, which requires the user to arrange 8 tiles in the correct order. First search, DFS, depth first search is a technique used to traverse trees or graphs. It begins at the root node and explores as far as possible along each branch before backtracking. It can be used to solve problems such as maze navigation and graph traversal. Breadth first search, BFS, breadth first search is a technique used to traverse trees or graphs. It begins at the root node and explores all the neighboring nodes before moving to the next level. It can be used to solve problems such as shortest path finding and maze navigation. A search algorithm. A is a popular search algorithm used for path finding and graph traversal. A combines the best of both breadth first search and depth first search. It explores nodes in the order of their estimated cost from the start node to the goal node. Hill climbing search. Hill climbing is a search algorithm used to find local optima in a search space. It works by starting from an initial state and then iteratively improving the state until it reaches a local optima. It can be used for optimization problems such as the traveling salesman problem. These are just some of the search algorithms used in AI. There are many more, such as genetic algorithms, simulated annealing, and particle swarm optimization. Each of these algorithms has its own advantages and disadvantages, and they all have their own applications. Machine learning algorithms. Machine learning algorithms are algorithms that enable machines to make predictions or decisions without being explicitly programmed to do so. Machine learning is a field of artificial intelligence which focuses on developing computer programs that can learn from data and improve over time. A common example of a machine learning algorithm is a neural network. Neural networks are used to recognize patterns in data and make predictions based on those patterns. For example, a neural network could be used to identify objects in an image, predict the stock market, or identify potential customers for a business. Other examples of machine learning algorithms include decision trees, support vector machines, and k-nearest neighbors. Decision trees are used for classification problems, such as determining whether a customer is likely to purchase a product or not. Support vector machines are used for regression problems, such as predicting the future values of a stock. K-nearest neighbors is used for clustering data, such as grouping customers based on their spending habits. Machine learning algorithms are used in a variety of applications, from facial recognition to self-driving cars. By using these algorithms, machines can make decisions or predictions that would otherwise require humans to do manually. For example, a self-driving car needs to make decisions about braking, turning, and avoiding obstacles, and a facial recognition system needs to be able to recognize a person's face. In both cases, machine learning algorithms can be used to automate the decision-making process. Chapter 3. AI Technologies. Natural Language Processing. Natural Language Processing, NLP, is a branch of artificial intelligence that deals with the ability of computers to understand and process natural language, such as English. It is used to analyze and interpret human language, allowing computers to understand and respond to commands given in natural language. NLP works by breaking down language into small components, such as words, sentences, and structure. It then uses algorithms and techniques to analyze the components, identify patterns, and draw conclusions. For example, a computer can use NLP to understand a sentence like "the cat ran away" by breaking it down into smaller components. It can identify that the sentence is made up of 2 nouns, cat and ran, and 1 verb, away. Then, it can use its algorithms to identify patterns and draw conclusions. In this case, the conclusion is that a cat ran away. Another example is a computer using NLP to understand a question like "what is the capital of France?" It can break down the question into smaller components and identify that it is asking for the name of a country's capital. Then, it can use its algorithms to search its database and find the answer, Paris. NLP has a wide range of applications, from voice recognition and machine translation to text analysis and document summarization. It is used in many areas, such as natural language processing, machine learning, artificial intelligence, robotics, and more. Computer vision. Computer vision is a field of computer science that focuses on the creation of computer systems that can understand, interpret, and analyze digital images. It involves the development of algorithms and techniques that enable computers to extract meaningful information from digital images and videos. The aim of computer vision is to enable machines to perceive and interpret the world in the same way that humans do. Computer vision algorithms allow computers to identify objects in images, recognize facial features, recognize text in images, and detect motion. For example, a computer vision algorithm can be used to recognize faces in an image. The algorithm will analyze the image and identify the eyes, nose, and mouth, as well as any other distinguishing features of the face. By comparing the image to a database of known faces, the algorithm can identify the individual in the image. Computer vision can also be used to detect motion, such as in a video. The algorithm will analyze the video frame by frame and detect any changes in the image. This can be used to detect movement of a person or object in the video. Computer vision can also be used for text recognition. This involves analyzing images of text and extracting the words and characters from the image. This can be used to read text from documents or images and can be used in applications such as optical character recognition, OCR. Finally, computer vision can be used in object recognition. This involves analyzing an image and identifying objects in the image. For example, a computer vision algorithm can be used to identify a particular type of car in an image. The algorithm will analyze the image and identify the features of the car, such as the shape, size, and color. Robotics. Robotics is a branch of engineering and science that deals with the design, construction, and operation of robots. A robot is a machine that can be programmed to perform tasks autonomously or with guidance. Robotics is used in a wide variety of industries, from manufacturing to healthcare. Robotics can be used to automate mundane tasks and to improve the efficiency of processes. In manufacturing, robots can be used to assemble parts, handle materials, and weld components. They can also be used to inspect products for quality assurance. In healthcare, robotic systems are used to carry out complex surgeries and to assist in diagnosis and treatment. Robots can also be used in hazardous environments, such as nuclear power plants or disaster zones, where they can perform tasks while keeping humans safe. For example, a robotic vehicle could be sent into a nuclear power plant to inspect the reactor core without exposing workers to radiation. Robots can also be used to explore remote or dangerous areas, such as deep sea or outer space. For example, robots have been used to explore the surface of Mars and to map the interior of the Great Pyramid of Giza. Robotics can also be used in entertainment and education. For example, robots can be programmed to interact with people in ways that would be impossible with humans. They can be programmed to play board games, or to act as a tour guide in a museum. Robots can also be used as teaching aids in classrooms, allowing students to explore and interact with the world in new and exciting ways. Chapter 4. AI Programming. Introduction to AI Programming. AI programming is a specialized field of computer programming where the aim is to create intelligent computer programs. It involves the development of algorithms and software that can reason, problem solve, and learn from experience. AI programming is often used in areas such as robotics, natural language processing, computer vision, and gaming. The goal of AI programming is to create machines that can act or think like humans. To do this, AI programmers must design algorithms and software that can interpret data and make decisions based on that data. For example, a robot arm in a factory might need to be programmed to recognize which objects it should pick up and place in a certain location. In this case, the AI programmer would need to create an algorithm that would allow the robot arm to recognize the objects and decide which ones to pick up. Similarly, a computer program designed to play a game such as chess might need to have algorithms that can analyze the game board and determine what moves are most likely to lead to a victory. In this case, the AI programmer would need to create algorithms that can evaluate the current game board and make decisions about which moves to make. In addition to creating algorithms, AI programmers must also be familiar with machine learning techniques. Machine learning is a type of artificial intelligence that uses data to learn and adapt. This means that AI programs can become smarter as they learn from experience. For example, an AI program might be able to recognize a specific type of object in a picture after seeing many examples of that object. AI programming is an important field of computer science. It has the potential to revolutionize many different industries and enable machines to act and think in ways that were previously impossible. AI programming languages. AI programming languages are languages specifically designed to enable computers to be more intelligent. They provide a way for developers to create and manipulate AI algorithms, and allow machines to interact with humans in more natural ways. Examples of AI programming languages include Python, Lisp, Prolog, and Java. Python is a popular AI programming language, and is widely used in a variety of industries. It is easy to learn, and has powerful libraries for data analysis and machine learning. Python is often used to create intelligent systems that can recognize patterns, learn from data, and make decisions based on that data. For example, a Python program could be used to detect fraud in financial transactions, or to recognize emotions in spoken conversations. Lisp is another popular AI programming language. It is used for AI research and development, and provides powerful tools for creating highly complex algorithms. Lisp is often used for artificial intelligence applications such as natural language processing and computer vision. For example, a Lisp program could be used to analyze images and recognize objects within them. Prolog is a logic-based AI programming language. It is used to create systems that are able to reason and make decisions based on facts and rules. Prolog is commonly used in robotics, expert systems, and natural language processing. For example, a Prolog program could be used to design an autonomous robot that can navigate a given environment. Java is another popular AI programming language. It is used for developing AI-based applications in a variety of fields. Java has powerful libraries for machine learning, natural language processing, and computer vision. For example, a Java program could be used to create an AI-based chatbot that can understand and respond to user queries. Working with AI frameworks. AI, artificial intelligence, frameworks are software libraries that provide a set of tools and algorithms designed to help developers create AI applications and products quickly and easily. The frameworks are designed to streamline the development process, allowing developers to focus on the core logic of their application, rather than having to write all the code from scratch. There are a number of different AI frameworks available, each with its own strengths and weaknesses. Popular frameworks include TensorFlow, PyTorch, Caffe, and Keras. Each of these frameworks has a different approach to building AI applications, and each is best used for different applications. For example, TensorFlow is a popular open-source library for building machine learning models. It has a powerful set of tools and algorithms that allow developers to quickly and efficiently build complex models. It also has a number of pre-trained models available, which can be used for common tasks such as object detection or text classification. PyTorch is another popular open-source machine learning library. It has a more flexible architecture than TensorFlow, allowing developers to quickly build custom models. It also has a number of popular pre-trained models, making it easy to deploy models with minimal effort. Caffe is a deep learning framework designed for image classification tasks. It has a wide range of features, making it suitable for both large and small image datasets. It is also highly optimized, allowing developers to quickly build and deploy models with minimal effort. Keras is a high-level API designed to make deep learning easier to use. It has a simple and intuitive API, allowing developers to quickly build complex models. It also has a number of popular pre-trained models, allowing developers to easily deploy models with minimal effort. In conclusion, AI frameworks provide developers with a powerful set of tools and algorithms to quickly and efficiently build AI applications. Each framework has its own strengths and weaknesses, and is best used for different applications. It is important for developers to understand the strengths and weaknesses of each framework and choose the one that best suits their needs. Chapter 5. AI Projects. Project Idea Generation. Project idea generation is the process of coming up with ideas for new projects. This process can involve brainstorming, research, and creative thinking to come up with creative solutions to a problem or challenge. It is an important part of the project management process and helps to ensure the successful completion of a project. For example, suppose a company wants to launch a new product line. The first step in the project idea generation process would be to brainstorm ideas for the product. This could involve researching the market and customer needs, then coming up with ideas for a product that would meet those needs. After the ideas have been generated, the project manager will then evaluate each one and decide which one is the best fit for the company. Once the best idea has been chosen, the next step in the project idea generation process is to develop a plan for the project. This plan should include the goals and objectives of the project, the timeline and budget, and any other details that need to be considered. Once the plan is complete, the project can then move on to the next step, which is implementation. This is where the actual project is carried out, and the results are monitored to ensure the project is completed successfully. Project idea generation can also be used in other areas, such as research and development. For example, a company may want to develop a new technology or product, but they don't know where to start. Through project idea generation, the team can come up with ideas for the product, research the market and customer needs, then develop a plan for the project. Once the plan is complete, the project can then move on to implementation and the results can be monitored. Project idea generation is essential for any successful project, and it is important to ensure that each idea is thoroughly researched and evaluated before moving on to the next step. By taking the time to generate and evaluate ideas, the project team can ensure that the project is successful and that the results are beneficial for the company. Building an AI project. Building an AI project involves several steps, including gathering data, designing a model, training the model, and deploying it. Gathering data. The first step in building an AI project is to gather the data that will be used to train the model. This can include images, text, and other types of data, depending on what type of AI project you are building. For example, if you are building an AI project to detect objects in images, you would need to gather a large dataset of labeled images. Designing a model. Once you have gathered your data, the next step is to design a model. This involves selecting the type of model you want to use and the parameters that will be used to train the model. For example, if you are building a deep learning model, you would need to choose the type of model, for example, convolutional neural network, the number of layers, and the parameters that will be used to optimize the model. Training the model. Once you have designed the model, the next step is to train the model. This involves feeding the model the data and adjusting the parameters until the model performs well on the training dataset. This can be an iterative process, as the model is adjusted and retrained to improve its performance. Deploying the model. Once the model has been trained, the next step is to deploy it. This involves packaging the model and its associated data and resources and deploying it to a server or cloud platform. The model can then be used to process data or make predictions in production. These are the steps involved in building an AI project. It is important to note that these steps can vary depending on the type of project and the specific requirements. Testing and debugging an AI project. Testing and debugging an AI project is a process that involves finding errors, verifying results, and ensuring the project runs correctly. Testing and debugging are essential for the successful development of AI projects. Testing is the process of executing a program with the intention of finding errors. It is the process of ensuring that the program runs correctly and produces the expected output. Testing may involve running the program with different sets of data and observing the results. For example, if a program is designed to recognize images, it may be tested with different images to make sure it can identify them correctly. Debugging is the process of finding and correcting errors in a program. Debugging is a process that can be used in conjunction with testing to identify and fix any issues in the program. To debug a programmer may use a debugger, which is a tool that helps to identify and fix errors in the code. For example, a programmer may use a debugger to analyze the program's code and look for any potential problems. Once the program has been tested and debugged, it is ready to be deployed. Deployment is the process of making the program available for use. This can be done by running the program on a server or hosting it on a cloud service. Testing and debugging are essential for the successful development of AI projects. Testing ensures the program runs correctly and produces the expected output, while debugging ensures any errors in the program are identified and fixed. It is important to test and debug an AI project before deploying it, as this can help to ensure it runs smoothly and without any issues. Chapter 6. AI Ethics. Responsible AI Practices. Responsible AI practices refer to the ethical use of artificial intelligence, AI, technology in order to ensure the safety and privacy of individuals, businesses, and the environment. Responsible AI practices are designed to protect individuals from potential harms, risks, and unintended consequences that could arise from the use of AI. Examples of responsible AI practices include: 1. Data protection. All data used for machine learning should be properly encrypted and stored securely. Additionally, AI systems should be designed to alert users when data is accessed, used, or shared in an unauthorized way. 2. Transparency. AI systems should be designed to explain their decisions to users in order to ensure trust and user understanding. 3. Fairness and equity. AI models should be designed to ensure that outcomes are not biased against certain groups of people. 4. Safety. AI systems should be designed to reduce risks and protect individuals from potential harms. 5. Accountability. AI systems should be designed to allow for traceability and accountability. 6. Human control. AI systems should be designed to allow for human oversight and control. 7. Privacy. AI systems should be designed to protect user privacy, such as by using anonymized data. 8. Sustainable development. AI systems should be designed to promote sustainable development and reduce environmental impacts. Social implications of AI. Social implications of AI are the effects that artificial intelligence, AI, has on the behavior and interactions of people and society as a whole. AI can be used to make decisions and take action in ways that can have a positive or negative impact on society. The use of AI can lead to a variety of implications, ranging from economic to ethical and political. One of the most significant social implications of AI is the potential for automation and job displacement. Automation is the use of technology to replace human labor in the production of goods and services. AI is being used in a variety of industries, from manufacturing to finance, to automate tasks that used to require human labor. This could lead to job displacement, as machines become more efficient and accurate than humans in completing tasks. Another social implication of AI is the potential for privacy concerns. AI systems are becoming increasingly powerful and are capable of collecting and analyzing vast amounts of personal data. This data can be used for targeted advertising, or it can be sold to third parties for various purposes. This raises ethical and legal questions about how personal data should be collected and used. Finally, AI can have a major impact on decision-making in various fields. AI is being used to make decisions in areas such as healthcare, finance, and law. AI-based decisions can be more accurate and efficient than human decisions, but they can also be biased and lead to unfair outcomes. This raises ethical and legal questions about how AI should be used to make decisions. Overall, AI has the potential to have a significant impact on society. It can help to automate tasks and make decisions more efficiently, but it can also lead to job displacement and privacy concerns. It is important to consider the potential social implications of AI before it is implemented in various fields. AI regulation and legislation. AI regulation and legislation refers to the laws and regulations created or implemented by governments or other legal bodies to regulate the development and use of artificial intelligence technologies. Regulation and legislation are necessary to ensure the safe and responsible use of AI technologies and to protect citizens from potential harms and risks. Examples of AI regulation and legislation include: 1. Data protection and privacy. Governments around the world have passed laws and regulations to protect personal data and privacy, such as the General Data Protection Regulation, GDPR, in Europe and the California Consumer Privacy Act, CCPA, in the US. These laws provide citizens with control over their personal data and require companies to take measures to protect that data from unauthorized access and misuse. 2. Algorithmic transparency. Governments and legal bodies have implemented laws and regulations that require companies to disclose the algorithms used in AI systems and to provide explanations for the decisions made by the systems. This helps to ensure that AI systems are being used responsibly and ethically. An example of this is the European Union's General Data Protection Regulation, GDPR, which requires companies to explain the logic behind automated decision-making when using personal data. 3. Safety and security. governments and legal bodies have passed laws and regulations to ensure that AI systems are safe and secure, such as the European Union's Cybersecurity Act and the United States Federal Aviation Administration's regulations on the use of drones. These regulations provide guidelines for the safe and secure development and use of AI technologies. 4. Ethical standards. Governments and legal bodies are increasingly implementing laws and regulations to ensure that AI systems are used ethically and responsibly. An example of this is the European Union's General Data Protection Regulation, GDPR, which includes guidelines for the ethical use of personal data. Additionally, the United Nations has released a set of ethical principles for the development and use of AI technologies. Chapter 7. Conclusion. Recap of AI concepts. Artificial intelligence, AI, is a rapidly developing technology that has the potential to revolutionize many aspects of our lives. It is the ability of machines to perform tasks that normally require human intelligence. AI has been a part of our lives for decades, but it has recently become more prevalent due to the rise of powerful computing hardware and algorithms. Some of the most common AI applications include robotics, natural language processing, vision and image recognition, machine learning, and more. AI can be used to solve problems in various fields, from healthcare to transportation. AI is also being used to develop autonomous systems and autonomous vehicles, as well as to improve decision-making, automate processes, and more. AI is quickly becoming an integral part of many industries, and understanding the concepts behind it is essential to taking full advantage of these new technologies. Future of AI. The future of AI is incredibly exciting and filled with potential. AI has already made incredible advancements in fields such as healthcare, finance, and transportation, and this trend is likely to continue. In the near future, AI could be used to automate more complex tasks, improve customer service, and even make medical diagnoses. In the longer term, it is possible that AI will be used to automate entire industries, revolutionize the way we work, and make the world a more efficient and equitable place. Ultimately, the potential for AI is limitless, and the possibilities are endless. And with that, we've come to the end of our course. Thank you so much for completing this course. Keep supporting for more courses.